Imagine a missile that doesn't just fly faster than its target can react. It thinks faster too. While enemy radar operators are still trying to understand what they're seeing on their screens, the AIM-260 has already calculated 17 different attack vectors, selected the optimal one, and committed to a kill solution they can't defend against. That's not science fiction. That's the weapon system the US Air Force has been testing since 2021, and it's designed to make every air superiority fighter China and Russia have invested billions in developing functionally obsolete. The AIM-260 Joint Advanced Tactical Missile represents the most significant leap in air-to-air combat capability since the introduction of beyond visual range engagement itself. Here's what you need to understand. For decades, the AIM-120 AMRAAM has been the backbone of American air dominance, a reliable workhorse that's proven itself in conflict after conflict. But the PL-15, China's long-range air-to-air missile, changed the calculus. With an estimated range exceeding 200 kilometers and an active electronically scanned array seeker, the PL-15 gave Chinese fighters a theoretical advantage in engagement range. Theoretical being the operative word, because the AIM-260 doesn't just match that capability, it renders it irrelevant. The range numbers matter, so let's be precise. The AIM-120D, the current frontline AMRAAM variant, has a maximum range of approximately 160 kilometers. The PL-15 pushes past 200, possibly as far as 250 kilometers depending on launch conditions. The AIM-260's exact range remains classified, but every indication from test data and procurement patterns suggests it exceeds 200 kilometers, potentially reaching 250 to 300 kilometers under optimal conditions. But here's what defense analysts and adversary planners are missing when they focus solely on range. The AIM-260 isn't just about throwing a missile farther, it's about creating an engagement envelope so sophisticated, so networked, and so adaptable that distance becomes just one variable in a multi-dimensional kill chain that no current adversary system can survive. Let me show you why. The AIM-260 uses a dual-pulse rocket motor, a propulsion system that fundamentally changes the energy management equation in long-range engagements. Traditional rocket motors burn continuously until fuel exhaustion, which means a missile launched at maximum range is essentially gliding for a significant portion of its flight, bleeding energy and maneuverability. The dual-pulse motor fires in two stages. The first pulse accelerates the missile to high speed during the initial phase. Then the motor shuts down, conserving fuel while the missile coasts toward the target area. When the engagement geometry is optimal and the target is within terminal range, the second pulse ignites, giving the missile a fresh burst of speed and energy exactly when it needs maximum maneuverability to defeat defensive maneuvers. That means an AIM-260 arriving at extreme range has the kinetic energy of a missile at medium range. Translation: it's just as deadly at 200 kilometers as legacy missiles are at 80. And here's what makes this devastating. That energy advantage compounds with every other system layer in the missile. The AIM-260 carries an advanced active electronically scanned array seeker that can track multiple targets simultaneously, discriminate between aircraft and decoys with unprecedented accuracy, and maintain lock through electronic countermeasures that would blind earlier generation seekers. While an adversary pilot is pumping chaff and flares and trying to break radar lock, the AIM-260's seeker is processing returns from multiple frequencies, comparing target signatures against known profiles, and adjusting its approach in real time. It doesn't just see through jamming. It uses jamming emissions as an additional data point for targeting. Think about what that means in an actual engagement. A Chinese J-20 stealth fighter detects an F-35 at extended range and launches a PL-15. The American pilot, operating with data from multiple networked sensors, already knows the launch occurred before the J-20's radar even acquired a firing solution. The F-35 launches an AIM-260 in response. Now both missiles are in flight, both pilots are maneuvering, both are deploying countermeasures. But the AIM-260 is receiving continuous targeting updates from the F-35, from other aircraft in the formation, from AWACS platforms operating hundreds of miles away, from satellite surveillance systems tracking the engagement from orbit. The missile isn't relying on its own seeker alone. It's operating as a node in a combat network that has a far more complete picture of the battle space than any individual Chinese pilot or aircraft could possibly generate. The PL-15, by contrast, is largely operating independently once it goes pitbull and activates its own seeker. Chinese data linking capabilities exist, but they're not integrated at the level American systems achieve. The PL-15 is hunting with the information it can gather from its own sensors and whatever final targeting data it received before the J-20 had to break off and defend itself. The AIM-260 is hunting with the accumulated sensor data of an entire air combat formation, processed and fused by artificial intelligence systems that can predict target behavior and optimize intercept geometry faster than any human operator could input commands. One missile is fighting alone, the other is fighting with perfect information. Layer 2 is where the AIM-260 transitions from superior to dominant. The missile is physically smaller than the AIM-120 it replaces, designed specifically to fit the internal weapons bays of the F-22 and F-35 without compromising their stealth characteristics. The F-22 can carry 6 AIM-260s internally, up from 6 AIM-120s, so no capacity gain there. But the F-35's internal bay, previously limited to 4 AIM-120s, can carry 6 AIM-260s due to the new missile's reduced dimensions and improved carriage interfaces. That's a 50% increase in magazine depth for the most numerous 5th-generation fighter in the American arsenal. An F-35 flying a combat air patrol mission now has 6 shots instead of 4. That doesn't sound revolutionary until you consider the mathematics of a large-scale air engagement. In a contested environment, the side that can sustain fire superiority longer wins. If an F-35 encounters multiple adversary aircraft and expends 4 missiles achieving kills or forcing defensive maneuvers, it's Winchester, out of weapons, forced to disengage or rely on external support. With 6 AIM-260s, that same F-35 can prosecute additional targets or have reserve capacity for defensive shots, extending its time on station and its ability to control the engagement space. Multiply that across a strike package of 20 F-35s and you're looking at 40 additional missiles in the battle space. That's not just more firepower. That's the ability to saturate defenses, to force adversary pilots into impossible decisions about which threats to counter first, to create a targeting overmatch that collapses enemy formations before they can coordinate effective responses. And the cost structure makes this sustainable. The AIM-120D costs approximately $3 million per unit. Early production AIM-260s are estimated at around $4 million, a premium, but one that decreases as production scales up and manufacturing processes mature. For a 33% cost increase, the U.S. Air Force gains a missile with 50% more range, significantly better kinematics, dramatically improved sensor fusion, and enhanced electronic warfare resistance. Compare that to the cost of developing and fielding an entirely new fighter aircraft to match adversary range advantages, which would run into the hundreds of billions of dollars and take decades to achieve operational status. The AIM-260 is the economical answer to a strategic problem, delivering asymmetric capability without asymmetric investment. Russia and China are both developing new long-range air-to-air missiles, the R-37M and various PL-15 derivatives, trying to match or exceed AIM-260 capabilities. But they're behind in the development cycle, behind in sensor technology, and critically behind in the network integration that makes American missiles more than just kinetic kill vehicles. They're building missiles for platform versus platform combat. The United States is building missiles for system of systems warfare, where every sensor, every aircraft, every data link contributes to every shot fired. That's not a gap you close with better rocket motors. That's a doctrinal and technological chasm that requires rebuilding your entire approach to air combat from the ground up. Layer 3 is about the tactical revolution this weapon enables. Air-to-air combat has been governed by the principle of mutual vulnerability for decades. If I can shoot you, you can probably shoot me, especially at extended ranges where both sides can employ their longest-range weapons. The AIM-260 disrupts that symmetry. An F-35 or F-22 carrying AIM-260s can engage targets from beyond the effective range of adversary missiles, but more importantly, can engage while remaining largely undetected until weapon launch. The stealth characteristics of American fifth-generation fighters mean that by the time an enemy radar has a reliable track, American missiles are already in flight, already inside the no-escape zone where kinematic advantages make evasion impossible. Here's the brutal, tactical reality. A formation of J-20s or Su-57s, even with long-range missiles, has to detect and track American fighters to employ those weapons effectively. Detection ranges against stealth aircraft are severely compressed. A conventional fighter radar might track a non-stealthy target at 200 kilometers, but that same radar might not achieve a firing solution against an F-35 until the range closes to 60 or 80 kilometers, well within the AIM-260's engagement envelope. So American fighters can shoot first, from a position where they're difficult to detect, using missiles that have superior kinematics and better terminal guidance. The adversary's response time collapses. They're reacting to missiles before they've even confirmed the presence of launching aircraft. And that's where the psychological dimension becomes a weapon itself. Fighter pilots are trained to trust their situational awareness, to build mental models of where threats are and what actions they need to take. When missiles start appearing on threat warning systems with no corresponding radar contacts, when aircraft in the formation start going down without clear indication of where the attack originated, that situational awareness degrades rapidly. Pilots become defensive, reactive, focused on self-preservation rather than prosecution of their mission. They burn fuel in hard defensive maneuvers. They expend countermeasures prematurely. They break formation cohesion, trying to evade threats they can't clearly identify. An organized strike package devolves into individuals fighting for survival. At that point, you've already won the engagement, even if you haven't achieved complete kills. You've denied the adversary the ability to execute their mission, which in most scenarios is the strategic objective anyway. The AIM-260 entered low-rate initial production in 2024, with full-rate production expected to ramp up through 2026. Initial operational capability was achieved in late 2023, meaning the weapon is already in squadron service, already being carried on operational sorties, already integrated into combat tactics and training. This isn't a future capability we're speculating about. This is operational reality right now. American pilots are flying with these missiles loaded in their bays. The only question is, what happens when they get used in actual combat? And given the performance parameters and the tactical advantages they enable, the answer is probably a very short, very one-sided engagement that ends with adversary aircraft falling out of the sky before their pilots fully understand what killed them. Layer 4 is about electronic warfare, an aspect of missile performance that often gets overlooked in favor of flashier metrics like speed and range. The AIM-260 carries electronic warfare systems that are classified in their specifics, but well understood in their general capability. The missile can operate in contested electromagnetic spectrum environments where jamming would render earlier missiles ineffective. It can receive targeting updates on frequencies that are difficult to intercept or spoof. It can employ its own electronic attack capabilities to degrade enemy sensors and communications. Think about that. This isn't a passive weapon that flies a ballistic trajectory and hopes its seeker works when it arrives. This is an active participant in the electromagnetic battle space, creating localized advantages even as it prosecutes its kinetic mission. Russian and Chinese electronic warfare systems are sophisticated, no question. Russian doctrine in particular emphasizes electronic attack as a primary tool for degrading NATO capabilities, but those systems were designed to counter the M120 and earlier American weapons, built on assumptions about seeker frequencies, data link protocols, and guidance architectures that the AIM-260 simply doesn't use. The entire electronic warfare playbook has to be rewritten. New jammers designed and tested, new tactics developed, all while American systems continue evolving. And here's the thing about electronic warfare. It's not enough to know what frequencies a system uses. You have to predict how it will adapt when jammed, what alternative modes it can employ, how it will coordinate with other systems in the network. The AIM-260 has multiple fallback modes, multiple ways to achieve terminal guidance, multiple paths to a successful intercept. Adversary electronic warfare systems have to defeat all of them simultaneously. That's not a technical challenge. That's a technical impossibility with current technology. The data link architecture deserves specific attention because it's central to everything the AIM-260 does well. The missile uses the Weapon Data Link Adaptive Network, or WDLN, a system that allows real-time, two-way communication between the missile and launching platform throughout flight. Earlier missiles used one-way or limited two-way links, sufficient for basic course corrections, but not for true collaborative targeting. WDLAN allows the missile to share what it's seeing with the launching aircraft, allows the aircraft to share updates on target behavior and threats, allows the entire engagement to be managed dynamically rather than committed at launch. If a higher priority target appears, the missile can be retargeted in flight. If the original target is destroyed by another weapon, the missile can be directed to a new aim point. If electronic warfare conditions change, protocols can be updated on the fly. The missile isn't following a predetermined flight plan. It's executing a mission that adapts in real time to battlespace conditions. And because this is a network-centric system, that adaptability extends beyond the individual missile. Multiple AIM-260s can coordinate their attacks, approaching from different vectors to saturate defenses, timing their terminal runs to arrive simultaneously so point defenses can't sequence their response, even communicating with each other to deconflict targeting and ensure each missile is prosecuting a unique aim point, rather than redundantly targeting the same aircraft. This is collaborative warfare at the tactical edge, artificial intelligence and sensor fusion, enabling behavior that looks like coordinated tactics, but happens at machine speed without human intervention. Adversary pilots aren't facing individual missiles. They're facing a distributed attack system that thinks and adapts collectively. Layer 5 is about integration across the joint force, because the AIM-260 isn't just an Air Force weapon. The Navy is integrating it for carrier-based operations, with the FA-18E F Super Hornet and future FA-XX platforms planned to carry it. The Marine Corps will employ it from F-35Bs, operating from amphibious assault ships and austere forward bases. This is a joint weapon system, which means tactics developed by one service inform tactics across all services, which means training and logistics and maintenance pipelines are unified, which means the industrial base producing these missiles achieves economies of scale that bring unit costs down and production volumes up. When you're talking about a weapon that might need to be produced in quantities of thousands or tens of thousands to equip the entire fighter fleet and maintain adequate stockpiles, that industrial base matters enormously. Current production plans call for ramping up to several hundred AIM-260s per year initially, with capacity to surge to over 1,000 annually if conflict requirements demand it. Compare that to Chinese production of PL-15s, which is estimated in the hundreds per year, or Russian production of R-77 variants, which is even more constrained by economic factors and supply chain limitations on advanced components. In a sustained conflict, the side that can maintain missile inventory wins, because running out of weapons means conceding air superiority, regardless of how capable your remaining aircraft are. The AIM-260 production base is designed from the start to be scalable and sustainable, using manufacturing processes that prioritize high-rate production and supply chains that aren't dependent on single sources or easily disrupted nodes. The international dimension adds another layer of strategic advantage. The United States has already indicated that close allies will have access to the AIM-260, with Australia, Japan, and likely South Korea identified as near-term recipients. That's not just about helping allied militaries. That's about creating a distributed capability across multiple theaters, forcing adversaries to plan for M260 employment in multiple scenarios simultaneously. China can't just prepare for American fighters carrying these missiles. They have to prepare for Japanese F-35s, Australian F-35s, South Korean F-35s, all employing the same weapon with the same overmatch capability. That dilutes any focused countermeasure development, spreads defensive resources thinner, and creates a coalition advantage that's more than the sum of individual national capabilities. And there's an economic warfare dimension here too. Every dollar China and Russia spend developing counters to the AIM-260 is a dollar not spent on offensive capabilities or economic development or social stability. The United States can afford to field sophisticated weapons at scale because the defense industrial base is robust and the economy can sustain that investment. Forcing near-peer competitors into spending races on defensive systems rather than offensive capabilities is strategically advantageous, even if those defensive systems eventually achieve some effectiveness. You're making them play your game, respond to your innovations, react to your timeline. That's controlling the tempo of military technical competition, which is nearly as important as winning individual engagements. Layer 6 is about what happens when these missiles are actually used in combat for the first time. No weapon system is proven until it sees real-world employment against a thinking adversary under actual combat conditions. But the test record for the AIM-260 is extensive and successful. Multiple live-fire tests against drone targets, including scenarios with heavy electronic warfare and multiple concurrent threats, have demonstrated high success rates. Captive carry tests on operational aircraft have validated integration and handling characteristics. Pilots who've trained with the weapon report high confidence in its capabilities and reliability. All of that builds a baseline of credibility. But the real proof will come in that first engagement, and everything about the AIM-260's design suggests that first engagement will be successful. The sensors are proven technology, evolved from systems already in service. The propulsion is mature and reliable, built on decades of rocket motor development. The guidance and control systems have been tested exhaustively. The data links work. The software is stable. The weapon handles correctly under all flight conditions. There's no single point of failure, no fragile component that could doom the mission, no untested assumption that could unravel under stress. This is as close to a sure thing as you get in military technology. And when it works in combat, when adversary pilots see their wingmen die to weapons they barely detected launched from aircraft they never tracked, that psychological impact will reshape air combat doctrine globally. Adversary air forces will have to make a choice. They can continue operating legacy platforms that are vulnerable to AIM-260 engagement, accepting catastrophic losses in any actual conflict. They can attempt to develop counters, investing years and billions in technologies that may or may not prove effective against American sensors and networks. They can pursue asymmetric responses, like long-range surface-to-air missiles or standoff weapons that avoid air-to-air engagement entirely. Or they can concede air superiority and plan operations that assume they won't control the air. None of those choices are good. All of them represent strategic concessions to American capability. That's what a dominant weapons system does. It doesn't just win fights. It prevents fights from happening on adversary terms in the first place. Layer 7 is about the future, because the AIM-260, as it exists today, is just the starting point for a family of weapons and a continuing evolution of capability. The missile's modular architecture means that components can be upgraded as technology advances. Better seekers, more efficient propulsion, enhanced electronic warfare packages, improved data links, all can be integrated into existing missiles or incorporated into new production lots without redesigning the entire weapon. That means the AIM-260 of 2030 will be significantly more capable than the AIM-260 of 2024. Even though they'll share the same basic airframe and designation, and there are variant developments already in progress. An extended range version with a larger motor or aerodynamic improvements to push engagement ranges past 300 kilometers. A counter-stealth variant with sensor packages optimized for detecting and tracking low observable targets. A surface-launched version that could be adapted for ground-based air defense, giving Army and Marine air defense units the same range and capability advantages currently enjoyed by fighter aircraft. A naval strike variant with a different seeker and warhead, optimized for attacking surface ships rather than aircraft. The AIM-260 platform is versatile enough to support all of those missions without fundamental redesign, which means the development investment pays dividends across multiple domains and mission sets. China is working on hypersonic air-to-air missiles, weapons that could theoretically engage at speeds above Mach 5 and ranges beyond 400 kilometers. If those programs succeed, they'll represent a new paradigm in air combat. But they won't negate the AIM-260's advantages. A hypersonic missile still has to detect and track its target, still has to maintain guidance through terminal phase, still has to defeat countermeasures and evasion. And a hypersonic missile launched from a detected platform is just a very fast warning that you're under attack, giving defending pilots more time to react, not less. Speed without stealth and network integration is impressive, but not decisive. The AIM-260 is designed for a battlespace where every advantage is contested, where adversaries have their own sophisticated capabilities, where winning requires not one overwhelming attribute, but a complete system optimized for success across all dimensions of the engagement. And that's what keeps American air dominance sustainable into the 2030s and beyond. Not one silver bullet weapon, but a networked, adaptive, continuously evolving system of systems, where the AIM-260 is a critical node, but not the only node. F-35s and F-22s provide the stealth and sensor fusion. AWACS and satellite systems provide the situational awareness. Data links provide the connectivity. Artificial intelligence provides the decision speed. And the AIM-260 provides the kinetic effect that turns information superiority into air superiority. Remove any one piece and the system degrades, but doesn't collapse. Adversaries have to defeat all of it simultaneously, which is beyond their current capabilities and likely beyond their capabilities for the foreseeable future. The strategic implications are clear and profound. Any conflict involving the United States and a near-peer adversary will begin with an air campaign, and that air campaign will be decided in the first hours by whoever controls the air-to-air domain. With the AIM-260, American fighters enter that fight with every advantage. Longer range, better sensors, superior networking, more missiles per aircraft, and the stealth to employ all of those advantages from a position of invisibility. Adversary pilots are fighting blind against an enemy that sees everything and strikes with impunity. That's not a battle. That's execution. And once air superiority is established, everything else becomes possible. Strike missions proceed without credible air defense. Ground forces operate without enemy air attack. Naval forces maneuver without threat from adversary air power. The entire joint force can operate at the tempo and with the freedom of action that military planners dream about, but rarely achieve in contested environments. Russia has already started reconfiguring its approach to air operations in response to what little they know about the AIM-260. More emphasis on long-range surface-to-air missiles, less on fighter-versus-fighter engagement. More reliance on standoff weapons launched from beyond American engagement ranges, less on close-range air superiority. That's a telling indicator. They're not preparing to fight for air dominance. They're preparing to avoid air combat entirely, which is a tacit admission that they can't win that fight. China is still pursuing air-to-air capability, investing heavily in J-20 production and PL-15 development, but their doctrine is also shifting toward anti-access strategies that emphasize missiles and denial rather than control. Both adversaries are adapting to a reality where American air superiority is no longer something to contest directly, but something to work around. And here's the final piece that makes all of this matter. The AIM-260 isn't a deterrent weapon. It's a war-winning weapon. Deterrents prevent conflicts by threatening unacceptable costs. War-winning weapons end conflicts quickly by achieving decisive results. If a conflict does occur, if diplomacy fails and missiles start flying, the side with AIM-260s dominates the air combat phase so completely that follow-on operations proceed on favorable terms. Wars are still decided by multiple factors: terrain and logistics, and strategy and will. But air superiority accelerates everything, enables everything, protects everything. The AIM-260 delivers that air superiority faster and more completely than any weapon in history. That's not the end of the fight. It's the beginning of a fight that's already decided. And adversaries know it.